Before we start testing with the AWS SDKs, I would like to mention that in order to delete a retained message via API calls or via device SDKs, we need to just make a publish call with the payload set to null or empty, right? And that retained message will be deleted for that topic. So once we're done with our testing, we'll go ahead in the console and delete all of our retained messages for all of our topics. Alright, so in the Boto3 documentation, we can see that there are 3 data plane API calls via which we can interact with retained messages. The first one is the publish call. This was there before, but they've added a retained message flag along with it. The second one is list retained messages. So this will return a list of all the topics that have retained messages for them. The third one is get retained message. This API call will give you back the message for a topic that has a retained message for itself, right? So in order to test this out, I have created a small piece of code that will make all 3 of these API calls. The first one is publish. So we'll publish to this topic with the retained flag set to true. Next, we'll list all the retained messages in this region. And thirdly, we'll get the retained message payload for each topic returned in this API call, right? So let's try it out. Great. So here you can see we made the publish call. Next, we got the list of all the retained messages. So I got this for AWS SDK Boto3. I got it for device SDK, and I also got it for console. So these are the 3 topics for which we had retained messages. So here it is. So we've got the payload for this one, and for this one, right? We can actually confirm this by going into the console, and here I'll just refresh, and we have all 3 of them over here, right? One last thing, we'll try and make all of the same API calls using CLI. So here's the documentation, and it's pretty much the same API calls in the same format. I've written down all 3 API calls in the same order. So the first one is publish, then list, and then get, right? One thing to note is that since I've updated my AWS CLI version to the latest version, version 2, I have to add this parameter in order to send a string payload, right? So let's try these out. I'm going to put them here, and let's paste it. This is the publish call with the retained message flag set to true. Okay, so this was sent. The next one is going to be list retained messages. So here it is. Here you can see that we got all 4 topics. The first one is CLI that we did right now, and the previous command. This one is from the SDK. This one is from the device SDK, and this one is from the console. Last, we have the get retained message API call. So I'll copy this and paste here. This will return a base64 encoded payload. So you can see it from the documentation for get retained message that it will return a payload that is base64 encoded. Lastly, let's delete all of these retained messages from this region. Since we created this retained message from the console, we'll go ahead and delete it from the console itself. So we just click on it and click on delete, and that's it. It's deleted. For the rest of the 3 topics, we'll publish an empty message and then delete them that way. So I'll go to the test client, put in the topic name, and delete the payload. Also, I'll set the retained message flag as true and publish a message. Now when I refresh this page, that one's gone. I'll do the same for the other 2, and we'll see that both of them get deleted as well. That's it. All of our retained messages have been deleted. Great. So we're done with the demos. Let's look at some considerations if you're going to be implementing retained messages in your application environment. AWS mentions that security is job 0, right? So let's take a look at how we can control who can publish a message with a retained flag set to true. So according to the policies that you can assign to certificates, along with IoT publish, we also need to give IoT retain publish. So if you do not give IoT retain publish, the client who uses those certificates to connect cannot send a message with the retain flag set to true. We can also control access on who can get and list retain messages by using the get retain message and list retain message actions in the policy. Looking at Impermissions, it's the same logic that whoever has the retain publish permissions can include the retain message flag in the publish API call. These are permissions for the same API calls that we discussed when we were making from the SDK. So get retained, list retain, and publish. Let's also take a look at pricing. So according to this documentation, the pricing for retain messages is the exact same as the pricing for messaging. So we can go to the pricing dashboard and we can see that it's up to 1 billion. We've got $1 and next 4 billion, 80 cents, and then over 5 billion, 70 cents, right? So we can also compare this to shadows. For shadows, you can see it's $1.25 per million operations, and it's the same, and it doesn't reduce as you scale. Whereas for messaging, it does reduce as you scale. Last thing you'd like to consider before implementing retain messages in your application would be how it compares to other features offered by AWS IoT. So those would be persistent sessions and device shadow. There's a really easy way to find differences between all three. So let's take a look at them. Retain messages are tied to topic name, and the publisher decides whether the message should be retained or not. So this is done by setting the retain message flag when it publishes a message. Persistent sessions are tied to a client ID, and the subscriber decides whether the QoS1 messages should be stored or not. And this is done by setting the clean session flag when it makes the connect call. Lastly, device shadows are tied to a thing name, and in this case, the architect or the admin will decide whether to use them. Right? So thing name inside AWS IoT. We can take an example by comparing retain messages and device shadow using this architecture sample. So this is two architectures. The first one uses device shadows and the next one uses retain messages. So in the first one, let's say we have a website that controls this IoT lamp. Here, the website would send a message to API gateway. API gateway will invoke Lambda functions, and then the Lambda functions will set the correct state of the device in the device shadow. And then once it's set, it will device shadows will then send a message to the IoT lamp asking it to turn on or turn off, right? So there's a disconnect between them because in case the IoT lamp loses connection or disconnects, it can come back and retrieve its latest state. Now we can remove both Lambda functions and the shadow service and instead just use a retain message. So in this case, API gateway will just make a publish call to that topic to which the IoT lamp is subscribed. And then even if the device loses connection and subscribes again, it will still receive the latest state. Thank you so much for watching, and get subscribed for more videos.